Afternoon, students. Can you hear me and see the screen?
Afternoon, sir.
Hold on a second. I need to correct something. Where is it? This thing has changed. How do I do this now? Let's see. Here you go. All right. All right, guys. So you can see the screen and hear me clearly, right? Everybody?
Yes, sir. See the screen.
All right, good. Well, Happy New Year. Nice to be doing maths on the first day of the year. Should set the tone for the rest of the year until we get to the exam in May. And this is the year that we're going to be doing the exam and have some fun and expect to get a lot of grade ones, straight E's, this exam in May, June. All right, so this is the last paper I gave you to do, and we're going to work through the questions I gave you on this paper. So I'm sure that I gave you number one. This is the June 2015 exam paper, as you can see here. And this is the same level of work that you can expect in your exam coming up. All right, so this is what I like to call a calculator question. It says using a calculator or otherwise determine the exact value. So it's almost like the same thing they ask every time. They want the exact value of this. And because they say you can use a calculator, you can literally type this expression in the calculator exactly as it appears there and just write the answer. And you have to get one of those calculators that we call it textbook display calculators. So you can type this thing exactly as it appears there. So starting out with a mixed number, and that mixed number is 2 and 2/5 if you look at the calculator. And then we are subtracting another mixed number. That mixed number is 1 and a third. And then we're adding yet another mixed number, which is 3.5. 3.5. And that is 4.56. But this is give an exact answer. So your calculator should be able to give you the answer in this form. All right, all we need to do is look and make sure we type the exact same thing there. Or can maybe give them this one down here, 4 and 17 over 30. Since they give us mixed numbers, we can give them back mixed numbers. Just want to make sure that the same thing that you have is what you typed here on the calculator. Just kind of double check it. 2 and 2/5 minus 1 and a third plus 3.5. Yes, that is it. And so that answer, I want to write this one equals 4 and 17 over 30. That's it. All right, because they did say you can use your calculator. All right, next part, same thing for this calculator again. So going back to the calculator, just gonna put it in again exactly as it appears there. So I'm gonna type this in the calculator exactly as it appears there. So it's an open bracket, 4.14. That's divided by 5.75 close bracket, and we're adding, and that's 1.62 squared. And that is 33.344. Let's say exact, so write out everything. Don't correct it, don't round it off anything. Just write the exact figure that we have there. 3.3444. That is it. Make sure the same thing you have here is what you type there. I'm just double checking. Divided by 5.75 plus 1.62 squared. Good, that is it. Just make sure you type the same thing in the calculator. That is that. These are like 3 marks questions. Just make sure you get them right. That's a total of 3 marks there just to do those calculations. All right. Again, I want this one. So how many of them they're giving us? I want this one again. So it's the same thing. Type this in the calculator up here. All right. So let's see. Clear the calculator. I'm going to do the same thing again. 2 times 3.142. And then we're timesing again 1.25. All right, 2 times 3.142 times 1.25. Yes, that is it. Equals 7.855. Don't correct it. Just give them the exact value that you got. That is it. That is the exact answer. 3 marks again. And this one, same thing. Put this in the calculator again, exactly as it appears there. This thing, put it in the calculator. And we're looking at the square root of 2.89 come from under the square root multiplied by the tan of 45 degrees. Now, you have to make sure the character is in degrees. If you look up all the way at the top up there, above the square root sign, you're going to see DEG. Some calculators will have DEG, some calculators will have D. I'm going to change it to radians right now so you can see it. See RAD, you don't want that. Alright, you don't want that. I also don't want GRAD. You don't want R, you don't want G. Some calculators will have R, some calculators will have G. What you want is D for degrees or DEG for degrees. I'm changing it back to degrees now. That's what you want. Once you're doing trigonometry, you want to make sure your calculator is in that mode. Degrees. At this level, you're gonna only be working in degrees. Alright? And that answer there is 1.7. So this is equal to 1.7. And that is the answer right there. And I think that finishes part A. But okay with that? But good? Nice and easy, right? 3 marks almost. But good with those?
Yes, sir.
Alright, beautiful. Now we'll come down to this consumer arithmetic question now. Alright, and it's simple stuff. Remember, we buy stuff every day. So you should not have a problem doing money questions. Same way you deal with money in real life, same way you're gonna do it in the mathematics. It's not complicated. Yes, there are some little specific things you have to learn about, like hire purchase and how to manipulate percentages and all of that. Profit, percentage, profit, percent loss. We're gonna deal with all of those in time. Alright, well, let's go. It says the table below shows a shopping bill prepared by Mrs. Rowe. The prices of some items are missing. Alright, so these are the items over here, and these are the unit cost. This is unit cost. That's the cost for one. That's what unit mean. Cost for one. Cost for one. Right? That's what unit mean. Alright, now there's 3 of this. Right? And this will be the cost for one. And this is the total cost over here. And what it is that you multiply these 2 figures and they become equal to this figure. That's how it is. Alright? Same thing on the next line. You multiply 4 times the unit cost to be equal to the total over here. And that's what you'll be doing. Down here is the same thing again. Multiply this value times the unit cost, and it is equal to this total over here. So you're going to be setting up some equations like that. Alright? Now, the first thing I want is for us to tell them the value of x. Unit, the cost for 1 kilogram of rice. Remember, this is 3 kilogram of rice is equal to this, you know. So therefore, it becomes 3 times x equals this. 3 times x equals that. Let's write it out. 3 times x is equal to 1080. I don't have to put on the dollar sign yet. 3 times x. Let's write this better. 3 times the x. 3 times the x is equal to 1080. So to find the x, I want to divide by the 3. So the x is equal to, if we can put the dollar sign on it, no problem, is equal to 1080 divided by 3. And then use the calculator and work that out again. So it's 1080, 10.80 divided by 3. That's 3.6, but because it's money, you have to put the 2 decimal places, right? So it's $3.60, 3.6. I'll put on the last 0 because it's money. You have to always write 2 decimal places. 2 decimal places when you're talking about money. That's the first answer there. X is 3.6, $3.60. But okay with that?
Yes,
But
sir.
good with that? All
Yes,
right,
sir.
good. Next part says, if the cost of 1 kilogram of rice, that's on the second line now, that's this is the cost of 1 kilogram of rice, is 80 cents more than 1 kilogram of flour. Now, so this price for flour here, 160. Now, this is 80 cents more. In other words, you have to add 80 cents. 80 cents is 0.80. So next you have to realize 80 cents is $0.80. This 80 cents is in dollars is 0.80. And you have to add this 80 cents to the cost of a flour, which is $1.60. You're gonna add these to find out what the cost of the rice is. So that's the cost of the rice, and the cost of the rice is Y. So we can set up like this. The cost of the rice, which is Y, becomes equal to 80 cents plus the cost of the flour. That's what you're working out. All right, and I want us to work out the Y and the Z. The Z is over here. So let me take this out. All right, that's what we have. So I want to work out the Y first and the Z. And remember now, to get the Z, you multiply these two. That will be equal to the Z. All right, so let's get the Y first. So the Y right here is going to work out to be, adding 80 to 160 becomes 240. 240, let me shift this over some more. $240. What can I agree with that? Why is 240? Very good.
Yes, sir.
And then this Z is equal to 4 times Y. So again, we'll set up like this. The Z that we want is now 4 pounds of rice, or 4 kilograms of rice, times the cost for 1 kilogram, which is 240, times 240. It's not complicated. So we're doing 4 times $2.40. We get 96, we get 9.6, which is $9.60. So that is $9.60. So these are your two answers right here. Very good. Are you okay with that?
Yes, sir.
All right. Next part now says a tax of 10% on the total cost of the 3 items is added to Mrs. Rose's bill. What is Mrs. Rose's total bill? What is our total bill? So the total bill is total cost plus the 10%. We can do this 2 ways. We can work out what the total cost is before the tax, and then we can work out what the tax is and add it. But I need you to understand that if you're adding 10% to the bill, then the new value of the bill is 110%. 110%. That's a new value of the bill. I need to understand that we can do percentages that way. If you're taking off 10%, if you're subtracting 10%, then the new value would be 90% of the original. We need to understand and do percentages in that simple way and reduce the amount of work needed. But let's go ahead and do it. Now, the thing is, what will be the total bill of add these 3 figures? What was the Z? The Z is 960. Let's put the 960 here. This Z is $9.60. And then add these 3 to see what the total is. Let's write total. That's the total before tax. So we're going to add up these 3 figures with the calculator over here now. So it's $10.80, 10.8 plus $9.60, 9.6 plus $3.20, 3.2. That's $23.60. So the total is $23.60. And then you're adding 10% to this. So the total bill, look at it this way, total bill is equal to 2360 plus 10% of the 2360. Shift this over some more. 10% of 2360. And that's going to give you the total bill if you wrote that out. That's the amount before tax, and then you're doing 10% of the total bill, adding 10%. And 10% basically you divide this by 10. So it's $2.36 that you're gonna basically add it. But you can work it out with the calculator. See it here on the calculator. $23.60 plus 10%. Calculator can actually give you a percentage as well of the 2360. Gonna get 25. Gonna get 25.96, right? 25.96. That's 25.96. That's the answer. Or we could do it another way. Look, or we could just add the 10% to the original, right? So the total bill is 110%. You're adding 10%, and the calculator the pen giving me some problems, guys. I need to get a new pen for this device. You're adding 10% to the bill. So the new bill, the new total is 110% of what it was, which is the 2330. If you do this calculation, you're gonna get the same answer. Alright, and I want us to learn to deal with percentages this way. If you're adding 10%, the new figure is 110%. Right? So if we just go ahead now and do 110% on the calculator times 2360, getting the same answer. Getting the same answer, which is 25.96. You did not have to work out, and some people actually work out that percentage first by itself and then add it. That's a waste of time. That's a waste of time. This calculation in red is good enough and get the answer quickly. But that is the end of that question, guys. Everybody all right?
Yes, sir.
All right, so that finishes that first question. All right, I think I gave you number 2 to do as well. So let's go down to number 2. All right, I don't think I need the calculator anymore. All right, let's go. So this one gives us A is 4, B is 2, and C is -1. That's what they gave us right here. These 3 figures. And I want us to work this out. You have to be careful with this negative sign, just in case you are adding a negative value. So this is going to become equal to, let's put them on each other. The A is 4 minus, and the B is just 2. So no problem here. No hanky panky, because the B is just 2. And they're adding, and then the C is -1. -1. If you add -1, like you're subtracting 1, so it really becomes 4 minus 2. This plus minus 1 becomes -1. So the whole answer works out to be 1, because 4 minus 3 is 1. That is it. But okay with that?
Yes, sir.
All right. Then now we're doing 2a to the b. So it's 2 times, and you're gonna have to work out the power part first. You have to work out the power part first. You cannot go multiplying the 2 times the a, because the a is under this power. The a is under the power of b, so you have to work out the a to the b first, right? The a right now is 4, as we said. So it's 2 times 4 raised to the power of b, and the b is 2. So that is 2 times, and this becomes a to the power of b. I have to work out this part first, as I said. That's 4 squared is 16, so it becomes 2 times 16. 2 times 16 is 32. And so the answer right there is 32. Alright, very good?
Yes, sir.
Okay.
Yes, sir.
Alright, let's continue. So here says, a bottle contains 500 ml of juice. Just think of this thing reasonable, rationally, right? It's not complicated. When write an expression for each of the following, the amount of juice left means you take out some amount. You want the amount left. You're starting with 500, you're going to take out some. the amount of juice left after pouring out P milliliters, and it was P milliliters in there. So the amount of juice left is going to be 500 minus P milliliters. See here? 500 minus P milliliters. That's the amount left right here. They just say write it down. See? Write. No calculation need, just write it down. What good with that?
Yes, sir.
Alright, this one now. So you're pouring out Q glasses. Q is the number of glasses, each containing R milliliters. So the total amount you're pouring out here is Q times R milliliters. I remember you're starting with 500. So this is the amount you're pouring out, Q times R. So the expression for the amount left here is going to be 500 minus Q times R, and that's in milliliters again. That's the amount left. If you up here, if you wanted to write 500 milliliters minus P milliliters, that would be okay as well. Down here, if you want to write 500 milliliters minus QR milliliters, that also be correct. So you could have written this or that, but what I've written in blue is okay as well. So I'm put an R in front of this, or you could write those as well. By the good, just checking as we go. Make sure everybody all right before we move on. By the good?
Yes, sir.
Good. Hope you all got these right. Then now they want us to write this as a single fraction. See, notice something frequent, right? A lot of people do this thing where they draw a line under here and the 3 times 5, 15, and the 3 into 15 goes 5 times, 5 times that. That is rote learning. I don't like to see it. We're just doing that by a process. When you're adding fractions, whether the fractions are numeric or algebraic, these are algebraic fractions because they have these unknown quantities in them. Right? You want them to be what we call related. Related fractions are fractions with the same denominator. Right now they are different. The lowest common multiple of these two denominators is 15. So if I take this denominator and multiply it up here and down here, the two denominators will be the same. And if I take this 3 and multiply it up here and down here, I will have same denominators and the fractions will be related. So it means that I'm going to multiply this fraction, numerator and denominator, by this denominator. So this is 5 over 5. And multiply this fraction by 3 over 3 to get the two denominators to be the same. So if the 5 times 2k is 10k, over 5 times 3 under here is 15, plus, then it's 3 times this 2 is 6, and 3 times minus k is minus 3k, all over this 5 times 3 under here is 15 as well. Now that the two denominators are the same, the fractions are related, they're going to have that common denominator as the answer. You just need to add the numerator values algebraically with this plus. So it becomes 10k plus minus 3k. 10k and minus 3k is the same as 10k minus 3k, which is 7k. And then there's nothing plus this 6. I'm going to put plus 6. And that is the answer. You cannot go now, for example, and divide this by 3 and put 5 and divide this by 3 and put 2. No, you cannot do that. If you're going to do that, you have to be able to divide everything on the numerator. The two terms on the numerator would have to be divided. Would have to be divisible by the same constant. So you have to leave your answer like this. You cannot simplify it any further unless you're going to write out separate terms and put 7k over 15 plus 6 over 15. Right? But the question said that's a single fraction. So you don't want these two, right? It said a single fraction. So we cannot do this. That's your single fraction right there. Want to go to that?
Yes, sir.
All right, nice. Let's go again. This one now. It says 4 mangoes and 2 pears cost $24. 4 mangoes, 2 pears cost $24. It says 2 mangoes and 3 pears cost $16. 2 mangoes and 3 pears cost $16. So that's a pair of simultaneous equations going to be setting up. It says, see there, write a pair of equations in x and y to represent the information. So what we're going to do, we'll have to decide what x is and what y is. So let's say x is the number of mangoes, right? X is the number of mangoes and y is the number of pears. It's a must state clearly what x and y represents. All right. So x represent mangoes and y represent pears. All right. So x represent mangoes. So we're gonna put x right here for the mangoes and y for the pears, and x for the mangoes, and again y for the pears. So the equation becomes 4x plus 4x, or x is the cost of a mango, right? No, x is the cost of a mango. It's 4 mangoes, right? X is going to be the cost of a mango, not the number of mangoes. X is going to be the cost of a mango, y is going to be the cost of a pear. And x is going to be the cost of a mango, y is going to be the cost of a pear. That's what it's going to be. So it's 4 times x, where x is the cost of 1 mango. So it's 4 times the cost of 1 mango plus 2 times the cost of 1 pear. Y is the cost of 1 pear. That total cost is $24 equals $24. Second equation is 2 times the cost of a mango, which is 2x, and 3 times the cost of a pear. 3 times the cost of a pear, that is $16. That's the 2 equations. And then asking you to state clear what x represents. X represents the cost of 1 mango. Cost of 1 mango. And y represent the cost of 1 pear. But you understand that?
Yes, sir.
All right, that is it, right? So x is not the number of mangoes enough. 4 was the number of mangoes, so x cannot be the number of mangoes. X is the cost of the mango, because it was 4 mangoes. We know the number of mangoes, but we did not know was the cost of the mangoes, of each mango. So it's 4 times the cost of a mango plus 2 times the cost of a pear is $24. So those x and y must represent the cost of the mango and the cost of the pear, respectively. And that is it. All right, let's continue. They don't want us to solve it, just that, right? It says state clearly what they represent. They don't want the value. They don't want us to work out the equations. All right, they just want us to write what they represent. You know, they want us to factorize these. All right. So here I see 2 terms. See a minus sign there, and I only see a common factor of a. And whenever you're doing a factorization, you have a common factor, especially with 2 terms. So it's not a trinomial like a quadratic. It's just 2 terms, a common factor a. I'm going to factor the a. I'm going to get a into, out of this, I'm going to have a squared minus, and this is going to become a 12. Now, I think if you leave the answer right there, CSEC will give you your marks, you know. I think if you leave it like that, you get your marks. How much marks for it? 1 mark. So I think if you leave it like that, they give you the marks. But I said completely, the fact of the matter is that inside here can be represented as the difference of 2 squares. Because see this 12, even though it's not a perfect square number, it can be written as the square root of 12 squared. So like a square root and square it back, that is still equal to the 12. So to express 12 as a squared number, you square root it and then square it back. Right? So I can create the difference of 2 squares inside here, even though this 12 is not a square number, like your 16 or your 25 or your 9. Right? But you can still turn this number into a square number in a sense. So if I were to continue and do that, I'm going to do that part in red as if to say, you know, this would have been okay. I think that would have been okay for this question. But if you really want to do it completely, right, we can turn this into a square by doing this. So we're going to factorize this a back. And then I'm going to write a squared minus and turn this 12 into the square root of 12 squared. Then this knows the difference of two squares. And so it will become this a out here. And I'm really not sure if CSEC wanted this that I'm giving it, but that this will be the full factorization. If we're actually going to factorize it fully, it will become a into, I'm going to apply the difference of two squares now inside here. So it will be a minus the square root of 12 and a plus square root of 12. So I really think that, well, I know that this is the complete factorization that I have here. But for 1 mark and do all of this square business, I don't think CSEC really wanted that. I think maybe they wanted to give a number like 16 on this question. You'll recognize that it is just 4 squared. But you know, we have to work with what we get. We don't know for sure. But this will be the correct thing, and you know, stuff like this, I learn from it, guys. Right? Learn that you can turn a number into a square number by squaring it, a number that is not normally a perfect square. So for example, I have 5 and I want to express it as a square number. I can square root it and then square back the result, and I've turned 5 into a square number. All right, just like that. All right, so stuff like this, you make sure you make it stick and you learn from it. But give them this in the exam, you're sure to get a mark for sure. If you give them this, I'm not 100% sure if this is what they're looking for. I'm not sure. All right, I'm not sure. They might, but the complete factorization would be this that I have down here now. But go do that. But okay?
Yes, sir.
All right. Then this now is your trinomial, guys, to factorize. And look here, this one easy. You don't need no process on this one. Because look, you have a prime number at the front and you have a prime number at the back. The only factors of 2 is 2 and 1. And the only factors of 3 is 3 and 1. And so it's just a matter of where you place them to get back in the middle term. Alright? So let's go. So this one don't need no process, guys. We have prime coefficients at the end. Alright? Easy. You have to learn these things. So I'm going to set it up and I'm going to write it the wrong way first and then show you how you would know it's the wrong way. So I'm going to write the only factors of 2x squared is 2x and x. Then the factors of 3 must go here and here now. Right? Factors of 3. So let's say I put the 3 here and 1 there. Right? Now, the fact that this last value is positive, it is telling me that the signs in the bracket are the same, you know. Same. Also, it is the sum of the far and the near product. The sum of the far and the near product that gives you this middle term. That gives you the middle term. The sum. When the last value is positive like that, it is the sum of the far and near product gives the middle term. The far product right now is 2x and the near product is 3x. Right? In fact, this is a correct way, you know, because 2x and 3x is 5x. It's just that when the two signs are the same, this tells you what they are. They are both negative. So let me start over again. Let me say it again. Let me say it again. Let me say it again. This plus out here tell me that the two signs in the bracket are the same. And this tell me what they are. So I know that the two signs are negative. Negative, negative. When the sign out here is positive, signs in the bracket are the same. Same signs in the bracket. And they are both negative. And that's when the first value is firstly positive. That's when the first value is positive. And most of them, the first value will be positive, right? So what I'm telling you now is when the first value is positive. So the two signs in the bracket are the same. Now, if you want to test if this is correct right now, you have to remember that the far product and the near product must add to the middle term. Now, the far product is 2 times negative 1, which is minus 2x. And the near product is negative 3 times x, which is minus 3x. These two add to minus 5x, which is the middle term. So therefore, this is a correct answer that I have here. Right? I thought I was writing it the wrong way first, but that is actually the correct answer. But what if I wrote it the wrong way? What if instead I put the 3 over here and the 1 over here? Let's change them around and see what will happen. So you could correct yourself. Let's put the 3 over here and the 1 over here. Right? Still I'm going to say this means that the two signs of the bracket are the same. Remember, to get this value, multiplying these two end values. And once the product of two numbers is positive, then it's either two positive numbers or two negative numbers. So the last value being a positive tells me that the signs in the bracket are the same. And this tells me what they are. So it's a negative and a negative. Same sign in the bracket. Alright? Now if I test it now and I go far product and near product, the far product will be negative 6x. This is 2x times minus 3 is negative 6x. And the near product will be negative 1x. These now would add to negative 7x. But my middle term is negative 5x. And that's why this will be wrong. That will be wrong. Even though it's the same values you have. You have to put them in the correct way. Put them in the correct order. Alright? So this will be wrong. Because the far product and the near product will add to negative 7. My middle term is negative 5. You have to learn these. Like a quick shortcut method to do in the question. So the correct way for these values is the 3 here and the 1 here. Because the far product is now minus 2x and the near product is minus 3x. And these two figures add to negative 5x. The far product and the near product gives you the middle term, which is negative 5x. And so that is the correct answer right there. When the end values are prime like these, guys, you don't need a lengthy process. Believe me, you don't need it. But the only factors of 2x squared is 2x and x. And the only factors of 3 is 1 and 3. So you don't need no lengthy process. Don't need no lengthy process. But okay with that?
Yes, sir.
Right? If it was 2x
Yes,
squared,
sir.
right? If it was 7, what would happen? If it was 2x squared minus 7x, the same plus 3, you have the same values. You have the 2x and the x same way. We have the 3 over here, the 1 here, and minus minus. That's what it would be. And the far product will be 6x minus 6, and the near product will be minus 1x to give it this minus 7x. You have to learn these things, guys. That would be what it was if, what it should be if this was a negative 7 instead of a negative 5. Alright, the 1 and 3 will be the other way around, but it will be the same two factors. Alright, so let's make note of that. Alright, let's continue. That finishes number 2. I'm sure I didn't give you number 3, but that's sets. Alright, we're going to be doing sets only on multiple choice. We're going to be doing this topic in the new year. Maybe around March or so. That's geometry construction. Close to the exam, we're going to be doing that one. Quite easy. I think I gave you this one to do because that's a quadratic, right? That's a quadratic. So it says the table below is designed to show the values of x and y for the function. That's a function, right? Remember, this is a quadratic function. It is symmetrical, about a line of symmetry or axis of symmetry, and it gives us the x values from negative 2 to 4 up here. And are there any gaps? This is by 1, that 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 is by 1. So all the values increasing by 1. Alright, so all these values are going to be symmetrical about a line of symmetry. You see this 4 right here? Alright, put it this way, we have negative 3 and negative 3. So it means that whatever value is here, it is the same value that is here. Just as the value after this is 5 and the value after this is 5. So if you can work out this value, then this is going to be the same value. Alright? So work out that value, for example, by placing the 3 in this function to see what this value is. So we can work it out right here on the screen. So I'm going to put 3 in this function. So this value right here becomes 3 squared minus 2 times 3 minus 3. That looks like a 0. But it says 9 minus 6 minus 3. So that's a 0. So this is equal to 0. So that's a 0. So it's automatically is a 0 as well because the values are symmetrical. And this is going to be an axis. your vertex. That's going to be your vertex, your minimum point right there. Because all the values are symmetrical about here, to the left and to the right. The values are symmetrical. I'm talking about the y values. The y values are symmetrical about this. Right? So imagine that this, your vertex pass through this point. Right? That is the axis of symmetry right through there. The values are symmetrical about that axis of symmetry, your y values. So it means that negative means that this point is your minimum point. Minimum point. All right, but let's see what they want us to do. So, so get the 0 and that, and remember where y values are equal to 0, these become your roots. All right, so we know that this is the minimum point. Let's write down some stuff. This is a minimum point. This represents a minimum point. These are your roots where the graph intersect the x-axis. These are your roots. Alright, and this is the y-axis intercept. See, 0, -3. This is the y-axis intercept. This is your intercept. So you can pick up those things from the table as well, even if you don't see the graph. This is the y-axis intercept. This is the minimum point. These are the two roots. The graph intersect the x-axis. The graph has a smile shape. And your axis is x equals 1. That's the axis, x equals 1. God. Minimum point is 1, -4. Alright. Well, that's what I want us to do. It says on the graph, first we want us to complete the table. So we did that, put in these two values. And then it says now on the graph on page 13, plot the graph of this function using a scale of 2 centimeters to 1 unit on the x-axis and 1 to 1 unit on the y-axis. Alright, let's go on the graph and do it. Let's draw it on the graph as if instructed. You have to be careful with the scale, you know. So scale going from -2 to 4 horizontally and going from -4 is the lowest value up to 5. So you have to kind of put in the axis away so you can, you know, accommodate all the values. Alright, so on the x-axis it is 2 centimeters to 1 unit. Alright, so we need to where our y-axis is gonna be. Where the y-axis is gonna be. So it's from -2 to 4. So you see they don't give it, you have to scale up this graph and be smart about it. Alright, you can kind of test it at the end here. So horizontally, you want to come 2 centimeters to 4. So let's say you put the y-axis here. Right, and this will be 1, 2, 3, 4. This will be -1, -2. So that will be okay if your y-axis is here. That's your y-axis. Alright, now next we're gonna put the x-axis. Now remember the y-axis, the x-axis. So below the x-axis is going to -4 and going up to 5. We're going 1 centimeter to 1 unit, right? 1 to 1. So you want to kind of be halfway in the graph. So let's say x-axis was here. And this would be 1, 2, 3, 4, 5, and 1, 2, 3, 4. So means that this original line that I've drawn can be your x-axis right here. So that's gonna be my x-axis. That's gonna be my y-axis. I'm gonna scale it up now. So 1, 2, 3, 4, -1, -2. And then on the y-axis, it is vertical is 1 centimeter to 1. So this is -1, -2, -3, -4, and then up here to 1, 2, 3, 4, 5. Alright, that's what we have. Let's put in the values now. So the values are symmetrical about 1, 4. But we have -2, 5. Let's put them on one at a time. So put them on in blue. -2 up to 5 right here. -2, 5. is right here. All right, next one is negative 1, 0. That's on the x-axis. Negative 1, 0. So negative 1, 0 is on the x-axis right here. And we have 0, negative 3, right? Sit here, 0, negative 3, the y-axis intercept. 0, negative 3 is right here. And then we have 1, negative 4, right? 1, negative 4, that's the vertex, the turning point. 1, negative 4, that's right here. And the values are no symmetrical about this line. So right across here from this, you're going to have another point over here. That's 2, negative 3. See? 2, negative 3. See there? 2, negative 3. And then 3, 0. Right? So, you know, we can know some of these things. What is that? No symmetrical. So, about this axis again. About this axis again. This is a 4 units to this. This is 4 units over to here as well. Alright, so it means that there's a root right here. 3, 0. Right here. And then now we'll go this number of units to go up to 5. So you go the same number of units to the right and go up to 5. Values are symmetrical. I'm trying to get you guys to appreciate the symmetrical nature of this graph. So that's it. Those are the points. And you draw a smooth curve. Remember, it has to be a curve you draw. Alright? You have to draw a curve. So you cannot come down like a V and go like that. You must turn at this point, like a turning point like that. Well, let's draw it now. Let me just draw it, right? Let's draw the best curve we can draw through the points. And that's it. That is it, not too bad. But okay with that?
Yes, sir.
Very good. Alright, what else do you want to? Alright, so then let's say now, complete the following sentence. So I've drawn a graph, a smooth curve, I plot the points and draw the graph. So I want us to plot the graph. I've done that and then we draw it now. It says complete the following sentences using information from the graph. It says the value of x, which the graph is equal to 0, are the roots. That's where the y equals 0 right here now. So where the y equals 0 is here and there. And those x values are the roots, negative 1 and 3. Negative 1 and 3, you can see it here as well. Additionally, you should know that this is a quadratic equation. And when you solve the equation, you get the roots. You get the roots. And the roots are the points where it intersects the x-axis, which is negative 1 and 3, corresponding to the negative 1 and the 3 here in the table as well. Everything consistent. So the x values are negative 1 and 3. Right? Those are the x values, the roots. Alright? Write the roots under here. The roots. Then it says the minimum value of the function. The minimum value is the lowest y value. The lowest y value in the graph is negative 4. They don't ask for the minimum point, that's for the minimum value. The lowest y value on the graph is at negative 4. So they don't ask for the negative point, they ask for the negative value. The minimum value, and I mean minimum, they ask for the minimum value, which is negative 4. The lowest y value on the graph. And it says the equation of axis of symmetry is the vertical line to the turning point. The turning point is 1, negative 4. So this is the x value, the turning point. Xt is this, and this is your yt. Axis of symmetry, remember, is x equals the xt value. So it's x equals 1. On the graph, it will be the vertical line through this point, like this. Use the purple. This will be the axis of symmetry. Vertical line through here. That's a vertical line passing through 1. are passing through this point, which is 1, -4. That vertical line is x equals 1. That's the equation of that vertical line. X equals 1, the axis of symmetry. So the answer for that one is right here. X equals 1. So whichever way you want to look at it, multiple ways to look at it, the end result is the same. Alright, but good?
Yes, sir.
One. Alright. That was a nice question. These are revision, guys. Revision. Alright, so finish this one. Did I give you number 5? I gave you number 5 to do? Number 5 can be a ratio question. Did I give you number 5? Let me see. Not sure if I gave. Yes, I gave you 5, A and B. Let's do it. I mean, we don't do speed time graph yet. Speed and distance, but we can do this question like a ratio. We don't have to do it like, we don't have to do this question like a speed equal distance over time. Alright, we don't have to do it that way. You cannot do it like a ratio. So because we don't know speed equal distance over time yet, the rates of change and so on, I'm going to do this question like a ratio. Alright, so they gave us this speed, 54 kilometers per hour. All this means is that the vehicle is going 1 hour to 54 kilometers if we're doing it as a ratio. For every 1 hour, it goes 54 kilometers. I know they want to know the distance traveling 2.25 hours. So we're going to multiply this ratio by 2.25. It's like a ratio, multiply it by 2.25. And 2.25 is 2.25. So we can recognize this as 2.25. And that's going to tell us how fast the distance it travels. This speed of 54 kilometers per hour in simple terms means that every hour it goes 54 kilometers. So in 2.25 hours, we just need to multiply this by the same 2.25. So we do this multiplication, we're going to get this. We're going to get this. 2.25 times that. 2.25 hours is equivalent to, or it goes, multiply this now by 2.25. Let me get the calculator for that. So 2.25 times 54. That's 121.5. 121.5 kilometers. That's the distance it goes. 2.25 hours. Right? If you speed equal distance over time and get it, no problem. But that's what it is. But okay with that?
Yes, sir.
Alright. Then down here now, it says calculate the time in seconds it takes to travel 315 meters, given that 1 kilometer per hour is 5.8 meters per second. So it means then this speed we can do this multiple ways, you know, guys. We can do this multiple ways, right? We can do this multiple ways because we can take this and break it down into meters and seconds, but we can just simply work from what they said here. Now, if 54 kilometers was the speed of the car and 1 kilometer per hour, 54 kilometers per hour was the speed of the car, and they are telling us that generally speaking 1 kilometer per hour is the same as 5/18 meters per second. And because here now they're asking us a question in meters and seconds, it would be good if we can find out this 54 kilometers is what it is in meters per second. So all we have to do to see what 54 kilometers is, 54 kilometers per hour is multiply this by 54, right? Because if 1 is that, we multiply this by 54 to see what 54 is. So multiply this by 54 to get this start to become 54. It means that 54, which is the actual speed of the car, it means that the 54 kilometers per hour that the car is going is the same as multiply this now by 54. So it would be 15, I think. Let me see, 5/18 and multiply that by 54. Right, 15. So it's going to become 15 meters per second. So that's the speed of the car. What does this mean now? What does this 15 meters per second. Let me do it right here. It means that it goes 15 meters every second. That's what it means, you know. In terms of speed, it goes 15 meters in 1 second. 15 meters in 1 second. That's the speed of the car. That's what this means. And you want to know the time it takes to go 315 meters. So it's multiply this number now, this ratio by a number that will bring the meter side up to 315. What number is that? To know what that number is, you divide 315 by 15. Alright, so if we go 315 divided by 15, that's 21. So that says 21, you know. So we're going to multiply this by 21 so that this becomes 315. So we multiply this ratio by 21 so that the meter side becomes 315. 315 meters in. Multiply this by the same 21, we get 21 seconds. So this is the answer right here. You go 315 meters in 21 seconds. And as I said, guys, this is not the only way to do this question. But I'm just presenting you with this method today because I'm just using it as a ratio. I want us to get comfortable doing these things almost like a ratio question, because that's what it is really. It's a ratio. Alright, but okay with that?
Yes, sir.
Alright, only you know it gives us this ratio. It tells us to give us this ratio and I want us to write it down to 1 to something, 1 to some number. Now a ratio, as this one is, can be multiplied or divided by any constant value or any constant unit of measure. And in this case, what you want to basically do is bring both sides to the same unit of measure so that you can divide out that unit of measure and just leave the numbers, leave the values. Alright, that's what it is. So the question is, how we get this meter into millimeters? Is 1,000 millimeters. Alright, because remember now, 100 centimeter is what 1 meter is. So this is same as 100 centimeter. And then 10 centimeter, 10 millimeter make a centimeter, so it becomes 1,000 millimeters. Millimeters. You could have just gone straight down to millimeters. Something that is good to remember for you to convert from unit of measure versus scales. The scale and unit of measure is kill him, dear Mister, don't commit murder. This is a meter. This is kilometer, hectometer, decameter, meter. This is decimeter, centimeter, and millimeter. Alright, and if you have 1 meter right here and you want to get it to millimeter, you add zeros here. So it means that 1 meter is 1,000 millimeters. So this 1 meter is 1,000 millimeters. That's just another way to look at it. So it means that 1 millimeter over here is equivalent, I should say 2 is a ratio. No, this really should be a ratio. I put equal there, but it should be a ratio to 1,000 millimeters. And you can cancel off the millimeters and get it down to 1 to 1,000. And that's the answer that 1 to x. X is 1,000. This is the answer that I'm looking for. Change this to a different color. Alright. Make it a little smaller as well. Alright, and this is absolutely necessary, guys. I mean, you know, you can know that 1 meter is 1,000 millimeters. Alright. Then this now, centimeters and meters. Same thing. You want to bring this side to meters, and also you want to reduce these two numbers. Those are divisible by 2. So firstly, it becomes 1 centimeter to 3 meters if I divide by 2. First I have divided by 2. So you can divide by any constant value or any constant unit of measure. So divide by 2 first, becomes 1 to that. And then the meter is 100 centimeters. So 3 meters, see here now, 1 meter is equivalent to 100 centimeters. And so 3 meters is 300 centimeters. So this ratio becomes 1 centimeter to 300 centimeters. Then you can cancel down the centimeters, divide both sides by the centimeters. And so it becomes 1 to 300, this last one. 1 to 300. That is the answer right there. What are to that?
Yes, sir. Yes, sir.
Redo the question, someone please. Alright, I'll write them over again. Right, I didn't ask you to this one. We're gonna do maps and scales at a later date. There's certain specific things about maps and scales that I'm gonna teach you, but I'm not ready for it as yet. Alright, so we'll leave this one for today. It's easy, it can be done again as ratio, but there are certain key things I want us to learn to do. Alright, so I didn't ask you to do part C, so leave in part C. And then I think the next question I'll do is number 9. Let me see. I don't think I gave you this one because this one is measurements. I'm gonna do this topic again after we finish trigonometry. But I gave you B to the right, 6B right here, which is your transformation. Alright. So there are certain things on this one you should know as soon as you look at it. Right? One, you should know that it's an enlargement. Right? This one has a prime on it. So this one is the image. And this one is the object. And if you compare one side, for example, this side, QR with QR here, this side is 2 units and this has grown to 4 units. That's a multiplier of 2. So the scale factor has a value of 2. But then they are pointing in opposite direction. Right? They are pointing in opposite direction. Because, for example, P is pointing down this way, but on this P is pointing up that way. So because they are pointing in the opposite direction, the scale factor is negative. So the scale factor is actually negative 2. Before you even start, that's what the scale factor is. Negative 2. Right? And this other question looks like this is the point, the center point between them. But the scale factor is negative 2. Alright? So you should know that before you even start doing anything. Alright. Let's read the question now though. It says the diagram below shows triangle PQR and its image P prime Q prime R prime after an enlargement at center C, point C. So they tell you it's an enlargement and tell that the center is this point. Alright, so they're helping you. Alright, let's see what they want now. They must ask you something about the scale factor. Must. Let's see what they want. It says use the information from the diagram above to complete the statements. It says the size of a scale factor is 2. See there? The size. Size means you don't put no positive or no negative on it. The size of the scale factor is 2. And you can just write it on 1 mark for it. You see it? This has grown from 2 to 4 by a multiplier of 2. That's the value of the scale factor. Or the size of the scale factor is 2. Size of it, the size. He said the scale factor have negative because, why is it negative? Because the image and the object, the image is inverted on the opposite side of the center and pointing in the opposite direction. See, they are on opposite sides of the center. And it is inverted, not inverse, no, inverted. These are keywords I wanted to use. It is inverted on the opposite side of the center and pointing in the opposite direction. They are on opposite side of the center. It is inverted. This was pointing down and this is pointing up. Every point is up in the opposite direction. Q is pointing so, Q is pointing so. R R is pointing this way towards the center. R is pointing towards the center here. R is pointing towards the center here. Opposite direction they're pointing. So it is inverted on opposite side of the image is inverted on opposite side of the center and pointing in the opposite direction. That's what I wanted to write out for this. So I give you 3 lines to write it. 3 lines to write it. Why is the scale factor negative? So let's write it out. The image is inverted, not inverse. Inverted means turn upside down. Inverted. On the opposite side of the center and pointing in the opposite direction. Now you should be able to get this and write it out. Why? Because Mr. Shaw gave you this on the must-know sheet about transformation enlargement. When the scale factor is negative, I gave you that. Why did Mr. Shaw give it to you? Because Mr. Shaw knows that CSEC will ask you questions like this, which you're seeing here now. That's why I gave you that on your must-know sheet. If there was 1 mark for it, we want that 1 mark. So we want to write the right thing to get the 1 mark. Let other people don't get the 1 mark. We want it. We want every mark. And that's why I put it on the must-know sheet, because I know that CSEC asks questions like this one. Why is the scale factor negative? And so I've given you a statement on the must-know sheet, which is this exact statement. What you should say when the scale factor is negative, or what happens when the scale factor is negative. The image is inverted on the opposite side of the center. The image and the object, they end up on the opposite side of the center, and they end up pointing in opposite directions. So the image is inverted on the opposite side of the center compared to the object and pointing in the opposite direction. That's why the scale factor is negative. But go to that, and that's why you all need to go and study the items on the must-know sheet. So when you get these things, you get them right in the exam, and you have to be guessing and spelling, right, and trying to remember stuff when you should just know. Study the items on the must-know sheet for me, please. Alright, I gave it to you. When I gave you the transformation, it's in the handout. That must-know page in the handout and transformation. This is in there. Alright, everybody good?
Yes, sir.
Alright, good. Down here now says, the length of PQ is root 13. Therefore, the length of P prime, Q prime. So this is talking about the length. I want the length of the image. Remember, for enlargement, the length of an image is the scale factor times the corresponding length of the object. So for this one, you're simply multiplying by the scale factor of 2. Talking about length. And length don't carry no unit of measure. So the length of P prime, Q prime, which is the image length, is simply K times the scale factor. But the scale factor is 2, you know, right up here, the scale factor is 2, you know, remember. So this length that I want is 2 times this length is root 13, square root of 13 units. Also the units out here. That's what I want. This. So again, I gave you this on the must-know sheet. That when it comes to distance and length, also distance from the center, scale factor affects distance from the center, and scale factor also affects the length on the image and the object by a scale factor of K, whatever scale factor is. So the length on the image is K times the length on the object. And they have given us a length on the object here, and what the corresponding length is on the image. So the scale factor times that length, that is it. I don't even have a look at the diagram to see it. That is it. Then they're going to ask us about area now. See it here? What is the area of triangle PQR in square units? So I'm going to go on the triangle because I want the actual area. You need to go and look at the diagram and see what that area is, right? PQR. Let's look at it. This is PQR and I want the area. So it's a right angle triangle, so let's use base times height. This side is 2 units, this side is 3 units. So it's half base times height, right? That becomes 3 units squared. So it becomes half, that's the area of the object. No, this is the area of the object. So the area of the object becomes half the base, which is 2, times the height, which is 3. So it becomes 3 units squared. That's the area of the object right now. PQ as the object. Alright, so we can show that calculation down here. Alright. So it's gonna become just show the working down here. It's gonna become half 2 times 3. That's the area of the object right now. Is 3 units squared. So write 3 squared units on this, right? 3 squared units or 3 units squared. So this is that working out for it. This is the working out for it. Just to show the working out in this space. Then it asks us for the area of the image down here. See? The area of the image now. That's the image now. That's the AI no. Remember now, when it comes to area, this is a relationship that you must know. Again, something I must know. Area of image of an enlargement now is k squared times the area of the object. K squared. That's a must know items and that a must know item again. So the area of P prime, Q prime, R prime is something times. What is that something? The scale factor squared, which is 2 squared, which is 4. 2 squared, which is a 4. 4 times the area of triangle PQR, right? Which is what? 4 times this, which is 12. 4 times 3. Remember the area of PQR is 3 units squared. So 4 times 3 is this 12 squared units right here. So that is how we're applying this. Area of image, which is the P prime, Q prime, R prime, is K squared. K squared. And the K squared will be 2 squared, which will be 4. Times the area of the triangle, and the area of the triangle is the origin, the object is 3. We worked out up here a while ago. 4 times 3 is 12. That is what they want. That is it, guys. If you remember these questions, write them over again, get them right. Alright, they're very easy. A lot of people gonna use 2 times again, you know. 2 times 8, 2 times 3 and put 6, you know. A lot of people gonna put 6 right there, which is wrong. Let us not do that. Let us remember that area is a product of 2 sides. That's why you have to square the thing. Right? Area is a product of 2 sides, and the scale factor is affecting 2 sides to give it the area. Alright? And that's why it becomes k squared times the area of the object. Just know this for area, know this for length and distance of enlargement. This one down is for area, this one up is for length and distance. Can we move on? Everybody good?
Yes, sir.
Alright, beautiful. Let's continue. Alright, so skipping over statistics. Statistics will come after we finish the measurement topics. Alright, this pattern thing again will come close up to the exam as well. But I think I gave you number 9 to do. Yep, I'll give you number 9. Alright. This one says a graph paper, a graph sheet is provided for this question. It says a teacher marks an exam out of a maximum of 120 marks, right? The marks are then converted to percentage. So the total marks is 120, and I convert them to percentage. It says calculate the percentage of a student who obtains 60 marks. 60 marks is clearly half of that, so that's 50%, right? If you want to show work, it would be 60 out of 120 times 100, that is 50%. So 50% is the percentage if you get 60 marks. And if you get 100 marks, it's clearly 100%, right? That one don't need no work. So two of them easy, you can just write the 50 and the 100 in about anyway. So 100 marks is 120 marks is 100%. It to be 120 out of the 120 times 100, that will be 100%. I don't like to show working out for stuff that don't need any working out, but still it's okay. Alright, so 60 marks is clearly half the total, that's 50%. 100 marks is clearly the whole, everything, so that's 100%. Then it says now, on the graph sheet, plot the graph to show the information. So we want to show that 60 marks is 50% and 120 marks is 100%. I'm going to end up with a straight line graph. Alright, so see down here now. Alright, so they put marks on, they didn't put on the marks first, but we need to go up to 120. They put out the percentage first, but not the marks. So can we go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120? Yes. So I'm going to put the marks down here. They didn't put it first, we're going to put it ourselves, right? So this is 20 marks, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 marks, 110, and 120 marks. And what did we say in terms of marks and percentage? 60 marks is 50%, meeting right here. Alright, so we're talking about right here is a point. And then 120 marks is 100%. Those meeting right here. Right here. And 0 marks is 0% naturally. So we're drawing a straight line right down the middle. That's our graph that I want. Alright, but let's put it in a different color. Let's put it in blue. So it will be a straight line right down the middle here. Something like that. Alright. So I'll work out some other ones. Like 30 marks will be 25%, right? Half as much. So 30 marks will be 30 over 120 will be 25%. So maybe around here. This is 20 and this is 30. So 25 will be around here. So we should be passing through that point. Right, so and then 90 marks will be 75%, 90 will be 75. See, we do it with a ruler because I can't draw a straight line on this. That's why I'm doing this, right? So 75 will be about here. These are 2 points that I should have a line pass through. Alright, so that's it. Stop here, can't go more than thing there. 120 marks, so that is it. But that's it. I will draw this with the ruler, guys. Remember, 0 marks is 0% for sure. So you must pass through the origin down here. That's the graph. Alright. That's the graph. graph right there. What does they want us to do with it? What do they want us to do with it? What do they want us to do? So draw the graph, which is this. Draw the graph. Then it says, candidate was awarded 95 marks in the exam. Use the graph to determine the candidate's percentage. Now, it says draw lines on the graph to obtain it. No, we can't actually work this out, so it's supposed to be, So it's 95 out of 120. So I would work it out on the side just to see what it's supposed to be, because you can, and then make sure the graph kind of match it. So it's 95 out of 120. Right? 95 out of 120 as a percentage. That's 79%. So 79.16. I was telling 79%, but you have to find the 95 marks. Right? You have to find the 95 marks and carry it up on the graph and get the percentage. So let's do that. So come on the graph down here, find the 95 marks. Where's the 95 marks? So here will be 90. So 95 will be right here between the 90 and 100. That will be a 95 marks, right? So coming up on the graph right between these two lines, that's a 95 marks line right here. So use the ruler and come right up in between here. And let's say I have to show these marks on the graph. And it comes right up to this. We know it's 95. Now I'm 79 now. In between there you have to draw your line, right? And we know it's about 79. So watch this now. This is 70 and this is 80. And there are 5 lines, so it's 10 divided by 5. So each line is 2. Each of those small lines is 2. So this is 70, 72, 74, 76, 78. That's 78 right here. And this is 9. This is 80. If you notice, we have marked it is right in between here. So this is pretty accurate. Pretty accurate. Coming right in between here. This is right between the 78 and the 80. So I'm going to write 79. So calculation is 79.16, but 60. Don't expect to put 79.16. What your graph give you. So I'm going to write 79, because you have to show that you use a graph. That's 79. Let's see what this question says. Hold on. Where am I answering? Up here, so sorry. Up here, so answer. 95 marks, 79%. Okay. 79%. Don't is a different question now. And see, you have to show these lines. So they're telling you, draw lines on your graph. Draw lines on your graph to show you obtain the thing. So that's it. And I put the big 79 out here for the examiner to see. I'm getting it from, right? And I put 95 down here as well. The examiner can see all these things. Down here now there's another question. Let me rub this out. It's not a different question. It says a candidate was awarded a grade of 85%. So now we know the 85% or more. A candidate is awarded a grade of A, if her percentage is 85% or more. Use the graph drawn to determine the minimum mark the candidate needs to obtain a grade A. So you want to get 85% or more. So the minimum mark corresponds to 85%. So when I come up on the graph, I can work it out now. I can see what 85% of 120 is and see what that is. So I say 85%. 85%. Where's the percentage symbol now? 85%. Hold on. Let's put 85 over 100. 85 over 100. 85% times 120. Put 80. 85 I need to put times 120. So we need 102 marks. So we know the answer is 102, but let's see what the graph gives us, right? Let's see what the graph gives us. So we need 85%. So come over on the graph now. We're searching for 85%. 85% is right between the 80 and the 90. So it's 80 right here, 82, 84, 86, 88. So it's right in between here. This is 84 and this is 86. So we're talking about right in between here is 85. We should know that's halfway mark between that interval between 90 and 80 and 90 is right here. So this is your 85 now. 85. I want to go across on the graph now and see what the corresponds. It's supposed to be 102. Alright, so it's supposed to be 102. So calculation is 102. That's what the graph gives us. That's the lowest mark percentage to get a grade A. Come across over here. We'll come right onto there. And then we read it down right here. So now looks like it's 102 for true. Let's see if we get 102. I'm down on this line. That's 100. That's 110. Yep, that's 102. See? 2, 4, 6, 8. That's 102. So correct. This corresponds to 102. Right? That is it, correct. So I'm gonna put 102 down here. 102 marks. To get a grade A, the minimum mark you must get is 102. That is it, and the graph shows everything. Nice. Bam, bam, bam. Better good at that.
Yes,
That
sir.
okay?
Yes, sir.
Now go and do it over by yourself. Alright? Want to get these marks, get these things right in the exam. Alright, functions now. Don't think I need a calculator for this. So here now we're given these two functions, f and g. First part wants g of 5, no problem. Put 5 in the g function to get g of 5. So this simply works out to be 5 squared, that's where the x was, 5 squared, minus this 1, put that over 3. So 5 squared is 25, 25 minus 1 is 24, over 3, 24 over 3 is 8. 24 divided by 3 is 8, that's it. Next part wants f to the minus 1, so we're doing the inverse of this function. So let's start by saying f equals 3x plus 2. Alright, f equals 3x plus 2, and I'm going to inverse it. Inverse it. Let me put it in a different color. I'm going to inverse this. Inverse it. When we inverse it, this f, which is range, becomes domain on the inverse function. This x, which is domain, becomes range on the inverse. So it's 3 times the range on the inverse is f to the minus 1 plus back this 2. You want to make this a subject now. Easy. Okay, over the 2, subtract it and then divide under the 3. So okay, over the 2 first, you're going to get x minus 2 and then divide 3 under here. Divided by 3. That leaves f to the minus 1 as a subject. And it means then that f to the minus 1 is x minus 2 over 3. And you're putting back the of x now. Of x. That's the answer right there. F to the minus 1. Next part wants us to form this composite function and we must factorize it when we're done. Alright? Remember that g of f means f into g. You have to remember that. Putting the f function into the g function. Let's write the two of them so we can, reminded of what we do. Let's write the two of them. So the f function is 3x plus 2 and the g function is x squared minus 1 over 3. These two functions will compositing. So let's copy this down, put it down here, and we are putting f into g, and f into g, that's what this is. F into g means that we're taking all of the f and bring it and put it into the g right here. That's how we put f into g to form this composite function, f into g. So that becomes g of f of x is f into g. Set up this construct. It becomes 3x plus 2, and you square that, see, square that, minus 1 minus this one, and divide that by 3. But I want us to expand it out and then factorize it, right? So we're going to have to expand this out and then factorize it. And so we don't have a lot of space to work. Let me make this a little bit smaller and zoom in. I don't want a lot of space. Alright, so let's make it smaller and zoom in. Alright, so we're gonna expand this now. We're gonna expand this perfect square. When we expand a perfect square, it becomes the first term square, which is 9x squared. Let me do this in a different color so I don't confuse results. Let me do it in purple. Do it in purple for you. Alright, good. So the first term squared is 9x squared. Then we'll do twice the product of the two. Of the twice product of these two things. So we'll do twice the product of the two. You multiply them first. That's the 3x and the 2. You get 6x. And then double that to 12x. You're going to get 12x as the middle term. And then the second term squared, that 2 squared is 4. And then that's now is just the expansion of this perfect square. We have to now subtract back this one over here. And you're dividing that now by this 3. Then this becomes gf of x becomes, let's work out the numerator now. It becomes 9x squared plus 12x. And then this becomes 3. 4 minus 1 is 3. Divided by 3. What happens now is that each of these values can be divided by this 3. So we can go ahead and do it. Divide each of them by 3. So it becomes equal to, divide this by 3, it becomes 3x squared. Divide this by 3, I get 4x. And divide this by 3, I get 1. And then we need to factorize this now. But it's easy to factorize because this is prime. All the factors of this is 3x and x. And all the factors of 1 is 1 and 1. So you get 3x and x. And the factors of the 1 is 1 and 1. Then the signs are positive. Signs are the same, sorry, and they are both positive. So it's positive, positive. And you can double check it. The far product and the near product give you by the middle term, which they do. Because the far product is 3x and the near product is 1x. 3x and 1x is 4x in the middle term. So you know you factorize it good. So basically that is it. Alright, and that finishes that. Nice question. But good? Or on the page.
Yes, sir.
Alright with that?
Yes, sir.
Yes, sir.
Alright, beautiful, beautiful. Alright, let's continue. Next page. Alright, so this we're not gonna do this yet. This coming up next, guys. Next topic. Next topic is these things, trigonometry, right? Okay, start our new topic in January. It's gonna be trigonometry. By the second week of January, we'll be doing these things. Alright, by the second week of January, we'll be doing all these trigonometry. We'll be doing number 10s. Alright, it's gonna be fun. It's gonna be fun, nice and easy. Fun doing trigonometry. Let's go. This one gives us these two matrices, A and B, and I want us to calculate the product. So we need to multiply these two matrices. Alright, there's only 2 marks to do it. Let's go. So we're multiplying 1 with 1, 2, 0, 1. Remember, you multiply the rows of the first matrix, that's these 2 rows, by the columns of the second matrix, that's these 2 columns. So to remind me, I put a line across these and a line down these. So I'm multiplying these 2 rows with these 2 columns. Alright, so when you multiply a 2 by 2 and a 2 by 2, you're gonna get back another 2 by 2. Let's put it here with 4 values. Then we get the red. 4 values. So the first value right here is positioned in the first row and the first column. So to get it, you have to multiply this first row by this first column. That's the row and that column. Or you multiply a row by a column. You multiply the first element in the row by the first element in the column, and then the second element in the row by the second element in the column, and you add the values. So it's first element times first element, second element times second element. Remember, using this row and this column right now. First element times first element, second element times second element. First element times first element, second element times second element. So it's 1 times 1 and 1 times 0. Now the 1 times 1 is 1, and the 1 times 0 is 0. So you're adding 0 to this. And that's the first pair. Then now, for this element out here, it is positioned in the first row and the second column. So to get it, you have to multiply this first row by the second column. Same way again. First element in the row by the first element in the column. Second element in the row by the second element in the column. First element times first element. Second element times second element. First element times first element. Second element times second element. So it's this row and this column. So it's 1 times 2 and 1 times 1. Now 1 times 2 is 2 and 1 times 1 is 1. So you're adding 1. Then we come to this element now, which is positioned in the second row and the first column. So to get it, we have to multiply this second row with this first column. I do them the same way again. First element times first element, second element times second element. First element times first element, second element times second element. This row times this column. First element times first element, second element times second element. So it's 2 times 1 and 3 times 0. The 2 times 1 is 2 and the 3 times 0 is 0. Then we come to the last value out here, which is positioned in the second row and the second column. So to get that, we have to multiply this second row by the second column. This is a second row, second column element. So multiplying this second row by this second column to get it. We'll do the same way again. First element in the row times the first element in the column. Second element in the row times the second element in the column. So we say first element times first element, second element times second element. First element times first element, second element times second element. 2 times 2 and 3 times 1. 2 times 2 is 4. 3 times 1 is 3. So it becomes 4 plus 3. When you have all those values there now, you just write the conclusion, what AB is. Product AB becomes 1 plus 0 is 1. 2 plus 1 is 3. 2 plus 0 is 2. 4 plus 3 is 7 out here. That's the answer. Next part says no. Show that the matrix product AB is not commutative. Remember, commutative has to do with the reversal of order. In matrices, if you reverse the order of multiplication, the result can be different. Alright, generally speaking, that's the case. In special cases, they can be the same, but generally speaking, if you reverse the order, the result is different. And they're telling us now to show that. So because we already know what AB is, to show it, we need to just calculate, or at least start to calculate BA, and we have to work out all of it. So let's start calculating BA, knowing that AB is this. So if we start calculating BA, it will be the B1, this one in front, which is 1201, in front of the A, which is 1123. And then now, if we start the calculation to work out the first value right here, it will be this row times this column to give us that first value. And it will be first element is a different color. It will be first element times first element, second element times second element. So it will be 1 times 1 is 1, and 2 times 2 is 4. And it will work out to be 5. So this would start out with a 5. I don't have to work out the rest of them now. Right? Let me shift this over some more. I don't have to work out the rest of them because once one value different, the matrix different. So this clearly is not equal to BA. It's not going to be equal to AB. Not equal to AB. And so you're done. See, you work out, you start work out BA. And the first value that you work out is a 5. While the first value in this one is a 1. So it means that they're not equal. I don't need to work out the rest of them to show it. Alright, clearly not that thing there. So I don't need to work out these. I don't need to work out the rest of them. First value already shows that they're not the same. What good with that? But okay? Hello?
Yes, sir.
Alright, so this and this not equal, right? You put up here 5 not equal to 1, so the examiner can see it. So something I want to just do like an indicator for the examiner can see it. The only want the inverse of a to the minus 1. What is a again? A is this one, right? Let me just copy it down from you so I don't have to rewrite it. So this one is a. Put it here. Alright. This is a, right? I want to work out a to the minus 1. So a to the minus 1. This is a. Is equal to 1 over the determinant of the a times the adjoint of the a, which is 1 over. Now what's the determinant? The determinant of a is this first diagonal product minus this second diagonal product. So this first diagonal product is 1 times 3, which is 3, minus this second diagonal product is 1 times 2, which is 2. That's the determinant on the a, which works out to be a 1. This works out to be a 1. The determinant is a 1. They're multiplying that now by the adjoint of the matrix. Now how do we get the adjoint? We interchange the elements on the first diagonal, interchange them. So this 1, 3 down here becomes 3, 1. So it's going to become 3, 1. Then the elements on the second diagonal, you leave them where they are and you change the sign. So this 1 stays where it is, but it changes sign to a negative 1. And this 2 down here stays where it is and changes sign to a negative 2. And then because this out here works out to be a 1, this matrix stays the same, right? Not going to become anything. So a to the minus 1 just becomes this. So it becomes 3 minus 1 minus 2, 1. That is the a to the minus 1 right now. This is the answer right here. But okay with that? Very good?
Yes, sir.
Yes, sir.
Beautiful. Here now gives us something else to do. It says this matrix is M, right? Calculate the value of M such that that determinant is 0. What that means? The determinant is 0. Two things that mean. it is singular, and it has no inverse. You have to remember this, right? When the determinant of a matrix is 0, it is singular and has no inverse. And when that is the case, where the determinant is 0, it means that AD is equal to BA, meaning that this diagonal product becomes equal to this diagonal product. That's why they become equal. That's why the determinant is 0. Because if this diagonal and this diagonal is the same, then when you subtract them, that's when the determinant becomes 0. So to solve this, we can put this diagonal product. That's the calculation we're going to use. This diagonal product becomes 2x times 3, which is 6x. It becomes equal to the second diagonal product, which is 2 times 9. That's the BA. 2 times 9 is 18. If you divide both sides by the 6 to get rid of this 6, you get x equals 3. Or we can say take this 6 and divide it on the here. Anyway you look at it, the x is equal to 3. And that is the answer right there. X equals 3. Are you okay with that?
Yes, sir.
Yes, sir.
Beautiful, beautiful. Then we come to part B, which is vectors. It says the position vectors of R, S, and T relative to an origin O are these. Those are the 3 position vectors. Alright? You want the modulus of OR. Which of them is the first one? First one. That becomes the length of the vectors, becomes the square root of this value squared plus this value squared. That works out to be 5, because this is 9 plus 16. 9 plus 16 is 25. Square root of 25 is 5. When we do trigonometry, we will recognize this as a Pythagorean triple. 3, 4, 5 triangle. That's 5 units this works out to be. That's it. Alright? Modulus of the vector OR. That's the length of it. Remember, why is it that modulus? Because this vector OR means to go from O to R. You go 3 to the left. 3 to the left. This is O. I want to reach I go 3 units to the left. 4 units up. R will be right here relative to O. And the modulus is asking us for the length of this line. That's the vector OR right now. And this is asking us for the length of this red line. So it's Pythagoras theorem that we have used right here. Alright, just to put it into perspective for you. Alright. Down here now, wants us to find the vector RS. Now RS, since we know the position vectors of the R and the S, let's write them out up here. So the OR is the vector minus 3, 4. Second one was the S, right? The OS is the vector 1, 1. And the last one was T, right? OT is the vector 5, negative 2. I'm just writing them out so we can look at them. So we're trying to find now the vector RS, which is OS minus OR. O times the last minus O times the first. So it's this one minus this one, right? So it becomes 1, 1. That's the OS minus OR is minus 3, 4. Careful with these negative signs. That minus minus right here means a plus. So 1 plus 3 is 4. And then 1 minus this 4 is negative 3. That's the vector RS. And no one ST. Same thing again. It's OT minus OS. O times the last minus O times the first. So it's OT minus OS. OT is this one. 5, negative 2 minus the OS is this one. 1, 1 equals 5 minus 1. That's a 4. And minus 2 minus 1 is negative 3. See, them equal vectors. So RS and ST are equal vectors right now. Alright, so they are parallel and they have the same length, but they're equal vectors. Let's see what they want us to say. it says using the results of combining vectors in B2 on page 33, justify that RS is parallel to ST and that RST is a straight line. All right, let's write them out again. All right, let's write them out. So we have the RS equals 4 minus 3. And we have ST equals the same 4 minus 3. All right, that's what we have gotten. And only are they parallel actually equal. All right, so copy this down here. Good. Let's almost use these results. So because they have the same thing, it implies for them equal the same thing, that RS is equal to ST. Right? So what do we have here? We have equal vectors and also a common point. Equal vectors are also parallel. Right? Alright, so we have parallel vectors because they're equal, right? So we have equal vectors are parallel. Them equal, them parallel, and they have the same length. So then so much shows them parallel they are. So we have parallel vectors. Second thing, we have a common point. So say S is a common point. So because we have these two things, parallel vectors and a common point, right? Equal vectors are parallel. Here we're talking about RS and ST, right? Parallel. And then we also have S as a common point. It means that the 3 points involved RS and T are collinear. So because we have parallel vectors, which is 1, and a common point, you can draw the conclusion and so therefore RST is a straight line, meaning the points are collinear. Collinear points on a straight line. End of this test. And that is that. I was still by the good.
Okay.
Yes, sir.
Yes, sir.
That was a nice way to start the new year, guys. We're gonna have a lot of fun going on today. A lot of fun. Plenty work. It's all gonna be fun. Promise you. Alright, and I really look forward to finishing up this thing with you guys and going to conquer the exam. Alright, so brace yourself and get ready. It's gonna be a lot of fun down the stretch. Alright, so get yourself ready. Know that we're gonna get serious as a judge. Alright, from now going forward. Don't want to leave any gaps. So going on to trigonometry and stuff. Today is what? Today is today's Thursday. We can maybe still do something Saturday. So I don't know. I'll send out a feeler if we want to go back to face on Sunday. I think we should go back to face on Sunday. I'll see and see when school opening and so if school opening Monday, then definitely we should go back to face on Sunday and start our new topic. I don't think we have any time to waste. So I think definitely we're gonna go back to face on Sunday, Monday, and start the trigonometry right off the bat. Kick off January with a bang. Alright, so that is the plan. I'll send it out in the group. But see you guys. See you possibly on Saturday. I'll let you know. Alright, I'll send a message in the group and see what is what. Alright guys, so bye. Have a great day for the rest of the New Year day. I will talk. Bye everybody. Tap. Gonna end it now.